There is a moment when you look up at the night sky, that infinite ocean of stars, and realize that every single point of light could be a sun, burning billions of miles away. And if every sun has its own family of planets orbiting around it, then how many other Earths are out there? How many skies shimmer with their own moons, their own oceans, their own sunsets, maybe even their own people looking back at the darkness, wondering the same thing? For so long, humanity believed we were alone. The only oasis in a cosmic desert, the only world where life dared to bloom. But now, we know better. In just a few decades, astronomers have confirmed the existence of over 5,000 exoplanets, worlds beyond our solar system, each a different chapter in the story of the universe. Some are fiery infernos where the air itself melts metal. Others are frozen wastelands, locked in eternal night. And a few, a precious few, sit delicately in that perfect balance where liquid water might flow, where life might begin. We call this the habitable zone. And somewhere inside that fragile ring of possibility might lie the answer to humanity's oldest question: are we alone? The search for these worlds didn't begin with billion-dollar telescopes or robotic missions. It began with something far simpler: a spark of curiosity, the same restless wonder that has followed our species since the dawn of time. For centuries, philosophers imagined other worlds. Poets wrote of twin Earths spinning around distant stars. But proof, real, scientific proof, came much later. In 1995, two astronomers, Michel Mayor and Didier Queloz, discovered something extraordinary, orbiting a star called 51 Pégase. It wasn't Earth-like, not even close. It was a massive gas giant, half the size of Jupiter, circling its star every 4 days. A world so close to its sun that its atmosphere was likely boiling away. It shouldn't have existed, not according to what we thought we knew about planetary systems. And yet it did. That single discovery shattered our old beliefs and rewrote the cosmic rulebook. Planets, it turned out, weren't terrestrial jewels. They were everywhere. Not miracles, but inevitabilities of physics and time. Since then, our instruments have grown sharper, hungrier, and infinitely more patient. In 2009, NASA launched the Kepler Space Telescope, a silent guardian that stared unblinking at one tiny patch of the sky for almost a decade. It wasn't much to look at a small square of darkness, no bigger than your outstretched hand held to the stars. Yet from that tiny window, Kepler discovered thousands of new worlds. Thousands. Just in that one small region. Think about that. Think about that. If a single patch of sky hides that many planets, then across the Milky Way, there must be hundreds of billions, maybe even trillions of worlds. Statistically, some of them must be like ours. Rocky, warm, blue, perhaps even alive. And yet, we've never seen one clearly. They're too far, too faint, lost in the blinding light of their stars. But when we can't see, science listens, because the universe leaves clues for those patient enough to hear them. The way we find exoplanets isn't by looking for the planets themselves, but by watching what they do to their stars. Sometimes, a planet passes in front of its star, blocking a tiny bit of its light. Astronomers call this the transit method. A minuscule, repeating dimming of starlight tells us something is there, another world, orbiting, casting its shadow across the cosmos. Other times, we detect a star Wabu, a dance caused by the invisible tug of a planet's gravity. This is called radial velocity. From these delicate ripples of motion and light, scientists can infer a planet's size, its orbit, even the presence of an atmosphere. It's like reading cosmic braille, translating faint patterns into worlds we can only imagine. Every flicker, every wobble, every whisper of data brings us closer to one dream: finding another Earth. But what does it really mean for a planet to be habitable? It's not just about temperature, or oceans, or sunshine. Habitability is balance, a fragile harmony between chaos and calm. Too close to the star, and water boils away. Too far, and it freezes solid. But temperature is only the beginning. A world needs the right atmosphere, thick enough to trap warmth, thin enough to breathe. It needs magnetic fields to protect against cosmic radiation. It needs chemistry, the raw ingredients of life: carbon, nitrogen, oxygen, hydrogen, and perhaps most importantly, it needs time, billions of years of stability. Because life, as far as we know, isn't an accident. It's a symphony that takes eons to play. So when we search for another Earth, we're not just hunting for dirt and air. We're searching for another miracle. Among the thousands of exoplanets we discovered, a few have captured our imagination. Kepler 1a6f, roughly the size of Earth, orbits a red dwarf star about 500 light-years away. It sits within the habitable zone, where liquid water could exist. Scientists call it Earth's cousin. Then there's Proxima Centauri b, the closest known only 4.2 light-years from us. It might have rocky terrain, maybe even an atmosphere, but its sun, a dim red dwarf, flares unpredictably, showering the planet with deadly radiation. And then there's Trappist 1, a tiny star with 7 rocky planets, 3 of which orbit in the habitable zone. Imagine standing on one of them, looking up to see 6 other worlds hanging in your sky, glowing like moons, each one a potential home, each one a reflection of what could be, or what once was. But the universe is never simple. For every Earth-like world we find, we discover 10 that defy imagination. Some are so close to their stars that they're literally being torn apart by gravity, like WASP-12b, whose atmosphere is being sucked into its sun, creating a glowing trail of vaporized gas. Others are made of solid metal, with molten rivers and temperatures hot enough to vaporize iron. There are worlds completely covered in oceans, thousands of kilometers deep, with no land at all. And some, called super-Earths, are massive rocky giants, with crushing gravity and alien skies painted by endless storms. These planets are real, not fantasy, not theory. And they remind us just how strange, how vast, and how endlessly creative the universe truly is. Every discovery humbles us. Every world we find makes our own seem all the more. So why do we search? Why spend billions of dollars on telescopes, satellites, and data chasing distant lights that might never lead to anything? Because this search isn't only about them, it's about us. Every exoplanet we find is a mirror reflecting something about who we are, about what we value. When we find a scorched gas giant orbiting too close to its star, we learn about fragility. When we find a cold, lonely planet drifting through space without a sun, we glean solitude. And when we find a world like Earth, small, temperate, resilient, we remember just how rare and precious our home really is. The search for exoplanets isn't a quest for escape. It's a journey of understanding, a reminder that even in a universe of infinite possibilities, balance and beauty are fragile things. And yet, deep down, what we truly seek isn't just another world, it's life. Not advanced civilizations or green Scandalians, but any sign, any whisper that life has taken root somewhere else. Scientists call these whispers biosignatures, traces of gases like oxygen, methane, and carbon dioxide that could only exist in balance if something living were there to sustain them. Already, the James Webb Space Telescope has begun searching for these fingerprints, splitting starlight into its colors to reveal the invisible chemistry of alien skies. We're not expecting to find messages or cities or faces. We're looking for the quietest sign possible, a chemical imbalance, a hint that says, I am alive. Because even that faintest signal would change everything. It would mean that life is not a miracle, but a pattern. Not unique, but inevitable. The James Webb Space Telescope, humanity's greatest eye in the sky, has already begun to reshape our understanding of the cosmos. It can see the birth of stars, the death of galaxies, and the atmospheres of worlds light-years away. But perhaps its most profound mission is yet to come. To find a planet that looks familiar. A pale blue dot circling a distant sun, glowing with the faint signature of oxygen and water. We may never visit it, we may never even see it directly, but the moment we confirm its existence, knowing, with certainty, that there is another Earth, would change how we see ourselves forever. For the first time, we wouldn't just hope we're not alone. Where? No. But this search forces us to face another question, one that has haunted scientists and dreamers alike for decades. If life exists elsewhere, where is everyone? It's called the Fermi paradox. In a galaxy of 400 billion stars, silence should be impossible. And yet, it's deafening. Maybe life is common, but intelligence is rare. Maybe civilizations rise and fall before they ever learn to reach across the stars. Or maybe we're the first beings in the Milky Way to gaze outward and wonder. If that's true, then the responsibility falls to us to protect this fragile world. To nurture it, to ensure the flame of consciousness doesn't go out before it can spread. Sometimes, I think about how incredible it is to be alive right now, to be the first generation in human history that knows, without question, that there are other worlds out there. For millennia we stared at the sky and filled the void with gods, myths, and monsters. But now, we look up and see something even more profound: possibility. Every exoplanet is a story written in light and gravity, waiting for us to read it. And we fragile, curious humans are the first storytellers. The cosmos isn't empty. It's full of voices we've only just begun to hear. Imagine a future, centuries or millennia from now, when humans finally cross the stars. Generation ships gliding silently through the dark, carrying the memory of Earth with them. Maybe they'll reach Trappist 20 and find alien seas under a crimson sun. Maybe they'll walk the quiet plains of Proxima b and watch twin shadows fall. And maybe, just maybe, they'll look back toward the faint we call home and whisper, "That's where it all began." Every dream, every discovery, every breath of wonder starts here. With us. With the scientists who build telescopes, the engineers who launch them, and the storytellers who remind humanity why we look up at all. Because, in the end, the search for another Earth isn't really about finding somewhere else to go. It's about remembering how lucky we are to be here, on this blue planet, suspended in the endless black. The only world for now, where we can breathe, dream, and love. Every exoplanet we find reminds us that this one is extraordinary. We look to the stars, not because we're lost, but because we're curious. Because wonder is our nature. Because the same universe that made us still has so much more to show. So tonight, when you look up at the stars, remember this. You're not just seeing light, you're seeing time, millions, even billions of years traveling across space just to reach your eyes. Every star you see could be a sun. Every sun could have worlds. And maybe, somewhere out there, someone is looking back. Maybe their night sky holds a small, familiar light, our sun, and they re-asking the same question we are. Is anyone out there? Perhaps, across the silence of space, two species gaze upward at the same moment, sharing the same wonder, dreaming of the same meeting. Until that day comes, we keep searching. We keep hoping, and above all, we keep looking up.